Welcome to Digital Learning DCE. I am Kousalya S, Assistant Professor from the Department of Mathematics. In this video, we are going to learn tangent plane for sphere and plane of contact, definition, derivation, corollary, condition for the plane to touch the sphere and examples. The learning objective of this video is to make students to understand and derive expression for tangent plane for sphere and plane of contact. To prove that sphere through the point of contact of the tangent plane is perpendicular to the tangent plane and find a condition for the plane to touch the sphere. Session outcomes. Students will be able to derive expression for tangent plane for sphere and plane of contact, and also to prove that the sphere through the point of contact of the tangent plane is perpendicular to the tangent plane and find a condition for the plane to touch the sphere and solve examples. Let us do the derivation of equation of a tangent plane to the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 at A whose coordinates are x1, y1, z1. Look at the figure, students. Let P be the tangent plane to the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 at A whose coordinates are x1, y1, z1. Let P of xyz be any point on the tangent plane P. Then vector CA is perpendicular to vector AP. If two lines are perpendicular, we know that we can write vector CA dot vector AP equal to 0. But vector CA is nothing but the distance between the 2 points, and it is given by x1 plus u, comma y1 plus v, comma z1 plus w. Similarly, vector AP is nothing but x minus x1, y minus y1, z minus z1. By substituting in the above equation, it becomes x1 plus u, comma y1 plus v, comma z1 plus w dot x minus x1, comma y minus y1, comma z minus z1 equal to 0. Just take the dot product of that is simple multiplication. You are going to get xx1 minus x1 square plus ux minus ux1 plus yy1 minus y1 square plus vy minus vy1 plus zz1 minus z1 square plus wz minus wz1 equal to 0. Rearrange these terms so that can be written as xx1 plus ux plus yy1 plus vy plus zz1 plus wz equal to x1 square plus ux1 plus y1 square plus vy1 plus z1 square plus wz1. Now add ux1 plus vy1 plus wz1 plus d on both sides of the above equation. So you are going to get, after simplification, xx1 plus yy1 plus zz1 plus u multiplied by x plus x1 plus v multiplied by y plus y1 plus w multiplied by z plus z1 plus d equal to x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d. Now use the above equation. The x1, y1, z1 is a point on the sphere. So the RHS of the above equation becomes 0. Therefore, the required equation of a tangent is given by xx1 plus yy1 plus zz1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus t equal to 0. This equation represents the equation of a tangent plane to the sphere. Now let us do condition for a plane ax plus by plus cz plus k equal to 0 may touch the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, and also to find the point of contact. Look at the figure, students. You can understand better. So now remember the line. If the plane ax plus by plus cz plus k equal to 0 touches the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, then the length of the perpendicular from center, that is C, to the plane AX plus BY plus CZ plus K equal to 0 is nothing but the radius of the sphere. You can understand that better by looking at the figure. You can see that perpendicular length from C to the plane is nothing but the radius of the sphere. So the required condition is modulus of minus AU minus BV minus CW plus K by root of A square plus B square plus C square equal to R. So this is the required condition for the plane to touch the sphere. Let us solve some problems based on this. The first problem, find the equation of a tangent plane to the sphere x square plus y square plus z square minus 4x plus 5y minus 3z minus 19 equal to 0 at the point minus 1, 2, 3. So here equation of a sphere is given, the point x1, y1, z1 is given. From the equation of a sphere, you can find the values of u, v, w and d, and x1, y1, z1 is given. The equation of a tangent plane to the sphere is given by xx1 plus yy1 plus zz1 plus u times x plus x1 plus v into y plus y1 plus w into z plus z1 plus d equal to 0. So from the equation of a sphere, you'll come to know that you'll get that u is equals to minus 2, v is equals to 5 by 2, w is equals to minus 3 by 2, x1, y1, z1 is minus 1, 2 and 3 respectively, and d is minus 19. Substitute all these values in the above equation. You are going to get, and after simplification, you are going to get the required equation as 2x minus 3y minus z plus 11 equal to 0. One more question of the same type. Find the equation of a tangent plane to the sphere 3 into x square plus y square plus z square minus 2x minus 3y minus 4z minus 22 equal to 0 at 1, 2, 3. The same procedure, students. You have to find u, v, w, d from the given equation of a sphere. You can look at the sphere. The coefficients of x square, y square, z square is 3. So divide the given equation by 3 on both sides. Then u is minus 1 by 3, v is minus 1 by 2, w is minus 2 by 3, and g is minus 22 by 3. Given that x1, y1, z1 is 1, 2, 3 respectively. So substitute all these values in the equation of a tangent plane to the sphere, and after simplification, you are going to get the required answer. Look at the simplification steps and try to get this answer. Next problem. Find the equation of a tangent plane to the sphere x square plus y square plus z square minus 4x plus 2y minus 6z plus 5 equal to 0, which are parallel to the plane 2x plus 2y equal to z. So let us here consider the equation of a sphere as equation 1 and the plane as equation 2. The equation of the plane parallel to 2 is given by 2x plus 2y minus z plus k equal to 0. Center of 1 is C, that is C from the equation 1 is 2 minus 1, 3, and radius of 1 is root of u square plus v square plus w square minus d. Using that equation, you are going to get as 3. If 3 is a tangent plane to 1, then the length of the perpendicular from C to 3 is nothing but the radius of the sphere. So substitute the points center and also the radius. So you are going to get, after simplification, k is equals to 10 or minus 8. Therefore, the equation of a tangent plane you can get by substituting in equation 3 as 2x plus 2y minus z plus 10 equal to 0, or 2x plus 2y minus z minus 8 equal to 0. One more problem similar to that. Find the equation of a tangent plane to the sphere x square plus y square plus z square equal to 9, which passes through the line x plus y equals 6, x minus 2z equals 3. Let the equation of a sphere as equation 1. and the line as equation 2. We know that any line passing through the line 2 is of the form x plus y minus 6 plus k times x minus 2y minus 3 equal to 0. So here find the center using equation 1. Center will be 0, 0, 0 and radius is 3. Plane 3 will touch the sphere 1 if the length of the perpendicular from the center of 1 to the plane is equal to the radius of 1. So use again the same formula, that is modulus of 0 plus 0 minus 6 plus k times 0 minus 0 minus 3 divided by root of 1 plus k the whole square plus 1 plus 2k the whole square equal to 3. After simplification, you are going to get the values of k as 1 and minus half. Therefore, the equation of a tangent planes are given by 2x plus 2y minus 22 equal to 9 and x plus 2y plus 2z equal to 9. To, to do all these problems and to learn the derivation of the equation of a tangent, I have referred the following books. Please look at the references. Thank you.